Here we're going to look at topic 86, example 2, simplify a rational expression. What is the simplified form of the rational expression? What is the domain for which the identity between the two expressions is valid? So again, we want to do our 3 steps. This problem is going to be done just how we did the previous example in 86.1. So step 1 will be to factor. Step 2 is going to be to state the domain. And step 3 will be to simplify or reduce, however you want to look at it. Okay, so let's get started. I'm going to rewrite the problem as 4 minus x squared plus 3x minus 10. Now, the first thing I realize or notice is that in my numerator, it's not in a standard form. So I'm actually going to swap those. I'm going to rewrite my numerator as negative x squared plus 4. So I'm just going to change the order of those, which we're allowed to do. It's addition, subtraction. We can move those around as long as we keep the signs together, or signs correct. The denominator, I'm not going to factor yet. We will get to it, but I'm not going to factor yet. The next thing is that my numerator, or really any term, but in my numerator, my first term is negative, and I really don't want that to be the case. Whenever we're factoring, whether we're using the AC method, the factor sum method, difference of squares, it's always going to be easier and more favorable to us if the leading term is positive. So to change that, I'm going to factor out a negative 1. By factoring negative 1, I would be left with positive x squared minus 4. Right? Both of my signs are going to switch. Okay, they're going to be flipped. So keep that in mind. And again, I'm just going to do one step at a time, so I'm just going to bring the denominator over as is for now. Okay, so up top here, let's write this in purple. This x squared minus 4 is the difference of squares. All right, x squared is a perfect square. We have a subtraction sign between, and the 4 is a perfect square. So my numerator would be factored into the square root of each of those. So x squared would be x, and the square root of 4 is 2. One of these groups is going to be addition, one of them is going to be subtraction. Now remember, this is the difference of squares. All right, so that difference of squares is going to give us these 2 expressions. Make sure you're familiar with that. It's going to save you a significant amount of time. All right, my denominator is trinomial, so I'm going to look for factor sum. My leading term is a 1, so I can use the shorter version and just find the factor sum. So I need factors of negative 10 that have a sum of 3. So 1 and 10, 2 and 5 are my only factor pairs. Obviously this first one's not going to work, but negative 2 and 5 would give me 3. So my factor pairs are negative 2 and 5. Let's just show where we got all of this from. So my denominator is going to become x minus 2, x plus 5. All right, step 1 is complete. We have factored. Now we're going to state the domain. So usually you can just look at it and visually see it, but I am going to list the exceptions or show the work just so you see where everything comes from. We would take x minus 2 equals 0 and x plus 5 equals 0. So if you solve each of these, you get your exceptions. So my domain, remember you cannot have a 0 in the denominator because the whole term will be undefined. So you set each group, each binomial in this case, set them equal to 0, find what those exceptions were. What is going to cause this group to be 0? Well, 2. What would cause this group here to be 0? Negative 5. So those are the numbers that we cannot have. So the domain is all real numbers except x equals 2 and x equals -5. So we've now listed our domain. So step 2 is done. And our final step is to reduce. So I'm actually going to rewrite the whole thing again. You wouldn't have to show this step, but I just want to make sure everything is clear. And I highlighted the previous one, so I don't want to overlap a bunch of colors. So I didn't change anything here. I'm looking for common terms or common groups, common terms in the numerator and denominator. The numerator has x minus 2 as well as the denominator, so I can cancel those out. Nothing else can be removed, so my numerator will stay with the -1 and the x plus 2, and the denominator will be x plus 5. Apologize, I'm losing my voice here. Having a lot of trouble talking while I finish this up. So your steps: factor, then state your domain, and then simplify the expression. If you can follow those 3 steps, again, I know the factoring will be a little tough, but if you follow those 3 steps, you will get the correct answer. Obviously, as long as everything is done correctly. But you should be fine. Don't stress yourself out. Work through the problems. Take it one step at a time, and you will get to the solution.